Hi students, today I am going to deal the topic automation from the chapter Introduction to PLCs from the subject Industrial Automation. Today I am going to deal the topic automation from the chapter Introduction to PLCs. Learning objectives. Upon completion of this presentation, you will be able to understand the concepts of automation and its definition, need for automation, types of automation, definition of industrial automation, need for industrial automation, advantages and disadvantages of industrial automation, and relay-based control panel and components of relay-based control panel. Upon completion of this presentation, you will be able to understand the concepts of automation, its definition, the need for automation, types of automation, definition of industrial automation and need for industrial automation, advantages and disadvantages of industrial automation, relay-based control panel, components of relay-based control panel. So, what is automation? As the name suggests, automation means to perform automatic operations by measure of different kinds of machines. It means to perform automatic operations by means of different kinds of machines. Automation is the use of control systems and information technologies to reduce the need for human work in the production of goods and services. Automation is the use of control systems and information technologies to reduce the need for human work in production of goods and services. In the scope of industrialization, automation is a step beyond mechanization. It is used to reduce the human interference and efforts. Automation is defined as a technique that can be used to reduce cost and improve the quality. These are the two important things this automation can do. It can be used to reduce the cost and improve the quality. Automation can increase the manufacturing speed and reducing the cost. It can lead to products having consistent quality, perhaps even consistently good quality. So it is a technique which is used to reduce the cost and improve the quality of your product. So automation is basically the delegation of human control function to technical equipment for increasing productivity. It is basically the delegation of human control to technical equipment for increasing productivity, increasing quality, reducing cost and increasing safety in working conditions. Increasing productivity, increasing quality, reducing cost, increasing safety in working conditions. Need for automation. Automation is needed to increase the productivity. Automation of factory or manufacturing or process plant improves production rate through a better control of production. It helps in improving the production rate by better control of production. It helps to produce mass production by drastically reducing assembly time per product with a greater production quality. Therefore, for a given labor input, it produces large amount of output. So, for a very short duration of time, you can produce large number of components in a very short duration of time. So, the labor cost is also reduced here in this case. So, automation is needed to increase the productivity. So, that is why we need automation. Then, automation is needed to improve the product quality. The second most important thing is First is to increase the productivity. The second one, why we need automation, is to improve the product quality. Since the automation reduces the human involvement, so the possibility of human errors also gets eliminated. So the possibility of human errors gets eliminated. Uniformity and product quality with a greater conformity can be maintained with automation by adaptively controlling and monitoring the industrial processes in all stages, right from inception of a product to an end product. So it helps in improving the productivity, product quality, because the intervention of the human is eliminated. So uniformity and product quality with a great conformity can be maintained with automation. Automation is needed to provide optimum cost of operation. It is needed to provide optimum cost. Integration of various processes in industry with automated machineries, they minimize the cycle times and efforts, and hence the need of human labor gets reduced. So the need of human labor gets reduced. Thus, the investment on employees has been saved with automation. So integration of various processes in industry with automated machineries minimizes cycle times and efforts, and hence the need of human labor gets reduced. Thus the investment on employees has been saved with automation. So it is needed to provide optimum cost of operation. Then automation is needed to reduce routine checks. Automation is needed to reduce routine checks. Automation completely reduces the need for manual checking of various process parameters. By taking advantage of automation technologies, industrial processes automatically adjust process variables to set or desired values using closed loop control techniques. So automation completely is needed to reduce the routine checks, completely reduces the need for manual checking of various process parameters. You no need to do the manual checking, you can automate your process so that the results will be displayed on the control panel. By taking advantage of automation technologies, industrial process automatically adjust process variables to set or desired values using closed loop control techniques. Automation is needed to raise the level of safety. So industrial automation increases the level of safety to personnel by substituting them with automated machines in hazardous working conditions. So industrial automation increases the level of safety to personnel by substituting them with automated machines in hazardous working conditions. Traditionally, industrial robots and robotic devices are implemented in such risky and hazardous places. So industrial automation is needed to raise the level of safety because it increases the level of safety to personnel by substituting them with automated machines in hazardous working conditions. Traditionally, industrial robots and robotic devices are implemented in such risky and hazardous places. So robotic devices can be implemented in risky and hazardous places so that the safety of the personnel is increased. So it is needed to raise the level of safety. Types of automation. Automation, we have different types. Building automation. Examples are lifts and smoke detectors. These are building automations. Scientific automations, that is examples are rocket launching. Industrial automation, automated bottle filling stations, steel factories, etc. Then office automation, that is printers and CCTV cameras, all these are there. Then light automation, that is street solar lighting. Okay, these are the different types of automations. We have building automation, scientific automation, industrial automation, office automation and light automation. building automation, scientific automation, industrial automation, office automation and light automation. So among these I am going to deal the topic of industrial automation. We have different types of automation, like we have building automation, scientific automation, industrial automation. We are going to deal with industrial automation, like for examples, bottling, filling stations, then steel factories, where in industry this automation process is taken into consideration. So automation takes a step further mechanization that uses a particular machinery mechanism aided human operators for performing a task. Mechanization is the manual operation of the task using powered machinery that depends on human decision making. On the other hand, automation replaces the human involvement with the use of logical programming commands and powerful machineries. Till now we have seen mechanization where manual operation of a task using powered machinery, it depends on the human decision making. The human will decide what to do, when to do. Like for example, we have water level controllers. Water in a tank will be filled, and after the brim of the tank is reached, what happens? You automatically switch off the motor, the power supply to the motor. So the filling of the tank is stopped. This is all manually controlled. But automation, it replaces the human involvement and it uses a logical programming command to operate the powerful machineries. So industrial automation, so we can define as industrial automation is replacement with computers and machines to that of human thinking. It is replacement of computers and machines to that of human thinking. The word automation gives the meaning self-dictating. The word automation gives the meaning self-dictating, or a mechanism moved by itself, that derived from Greek word auto and matos, where auto means self while matos means moving. So automation, industrial automation is the replacement with computers and machines to that of human thinking. The word automation gives the meaning self-dictating, or a mechanism moved by itself, that derive from the Greek words autos and matos, where auto means self while matos means moving. So today's highly increasing competitiveness over the industry demands high quality and most consistent products with a competitive price. So today's increasing competitiveness over the industry demands for high quality and most consistent products. So need for automation. To address this challenge of industries considering various new product designs and integrated manufacturing technologies in parallel with the use of automated designs, one of the remarkable and influential moves from getting the solution of above mentioned challenges. What are the mentioned challenges? You need a new product design and integrated manufacturing technique wherein your product is wherein the quality of the product is high and it is more consistent. So these challenges can be fulfilled by the word automation, industrial automation. It facilitates to increase the product quality, reliability and production rate while reducing the production and design cost. So the production and design costs are reduced by adopting new, innovative and integrated technologies and services. So industrial automation, it facilitates to increase the product quality, reliability and production rate. It facilitates to increase the product quality, reliability and production rate while reducing production and design cost by adopting new technologies, new innovative and integrated technologies and services. So thus industrial automation is needed for optimizing the use of process control equipment. These are the reasons why we opt for industrial automation, that is to optimize the use of process control equipment, to decrease the response time for process and equipment contingencies, to provide information about process status, to manage process logic at floor level, and increase overall productivity and plant efficiency. So these are all the parameters, all the points that is needed, that is the reason why we need industrial automation. Industrial automation is needed for optimizing the use of process control equipment, decreasing the response time for process and equipment contingencies, provides information about process status, manages process logic at the flow level, increases overall productivity and plant efficiency. It increases the overall productivity and plant efficiency. The definition of industrial automation. In a brief, industrial automation is defined as the use of set of technologies and automatic control devices that results the automatic operation and control of industrial processes without human intervention and achieving superior performance than manual control. Okay, so we can define on industrial automation as the use of set of technologies and automatic control devices that results in automatic operation and control of industrial processes without significant human intervention and achieving superior performance than manual control. So these automation devices include PLCs, PCs, PACs, etc. and technologies include various industrial communication systems. And the technologies include various industrial communication systems. So industrial automation can be defined as the use of set of technologies and automatic control devices that results in the automatic operation and control of industrial processes without significant human intervention and achieving superior performance than manual control. So these automation devices include PLCs, PCs, PACs, and technologies include various industrial communication systems. So the tools of automation are, there are different tools which are used for industrial automation. They are programmable logical controllers, PLCs, supervisory controller and data acquisition, that is called SCADA, human machine interface HMI or touch screen TS, and variable frequency drive VFDs. So these are the various tools which are used for automation. In industrial automation we use these tools. The first one is the PLCs, programmable logic controllers. Then the second one is SCADA, supervisory control and data acquisition systems. Then we have human machine interface HMI or touch screens TS, and variable frequency VFDs, variable frequency drives. Then coming to the advantages of industrial automation, they are replacing human operators in tasks that involve hard physical or monotonous works. So this is one of the advantage with industrial automation. They are replacing the human operators, especially in where we are using them for hard work and physical labor. Hard physical work is needed and monotonous work, and they are replacing humans in tasks done in dangerous environments, where like in blast furnaces or in high temperature areas where the human cannot interface, human operators cannot be used. And in performing tasks that are beyond human capabilities of size, weight, speed, endurance, etc. And economy improvement. Automation may improve in economy of the enterprise, society, or most of the humanity. So these are the advantages of industrial automation. They are replacing human operators in tasks that involve hard physical and monotonous work. When people feel very bored doing the same work again and again, so they feel it that type of work is called monotonous work, and they are replacing humans in tasks done in dangerous environments, where the environment is hazard, where you're using hazardous chemicals are used, or in environment where high temperatures are used, where human access is not possible so easily. In those areas, industrial automation, they are being replaced by humans. Humans are replaced by automation. And then performing tasks that are beyond human capabilities of size, weight, speed and endurance. And economy improvement. They helps in improving the economy of the enterprise or the society or most of the humanities. Then disadvantages of industrial automation. Disadvantages: employment rate increases due to machines. Unemployment rate increases due to machines replacing humans and putting those humans out of their jobs. This is one of the most first and foremost disadvantage with industrial automation, because the people are removed from their jobs, because of which unemployment rate is increased. And technical limitations also, and security threats. Because of security threats, sometimes you don't use industrial automation, and a high initial costs. So these are the disadvantages of industrial automation. That is, unemployment rate increases, then technical limitations are there, then security threats are there, and high initial costs. Security threats and high initial costs. Then, so coming to the automation, how this actual automation is carried out. How the actual automation is carried out. So, in recent years, automatic control systems, they have assumed a very important role. They played a very important role in development and advancement of modern civilization and technology. Automatic control systems, domestic applications like heating and air conditioning, in various industrial applications like quality control of manufactured products, automation, machine tool controls, space technology, weapon systems, all these areas, the advancement, the usage of automatic control systems have been very, very important. So what is a system? What is a control system actually? A system is a combination of individual components that act together to perform a specific task. To produce an output corresponding to the given input, some certain set of rules must be followed. There are different types of systems we have: the electrical, the mechanical, the hydraulic, the pneumatic, the chemical systems, the analog and digital systems we have, and combination of various systems, they constitute a process. Wherever these dynamic variables are controlled manually or automatically, we term that system as process control. So different parameters or different variables we are controlling, and these variables are dynamic in nature. So automation has made the control of process simpler. Automation has made the control of process simpler, and it became more precise, and it is faster and more reliable. If the plant size is large, it is impossible to start or stop any drive or device manually. Okay, so automation from a centralized control panel is essential now. So the startup or shutdown of a process of complete plant has a logical sequence. So there is a specific process or logic is being followed, which is specified by the process engineer. You cannot shut down any process automatically or randomly. Everything is is going in a sequence. So startup or shutdown of a process of a complete plant has been done in a logical sequence. So this sequence must be specified by the process engineer. So that sequence must be specified by the process engineer. Like for example, specific conditions like you may be having many devices to start. There are many interlocks that are necessary for safe operation of the device. During the operation of the device, a particular interlock does not remain true. Then the device needs to be stopped. Okay, there are different set of interlocks we will be using in this logic, process logic. So when that task is not done properly, when it's not true, then the device needs to be stopped for the purpose of safety or preventing any damage to the device. So this abrupt stopping of the device is called tripping. So implementation of logic control involves the following steps. First, you need to understand the process which requires a logic control. So you first of all, in any process control system, in any industry, process control industry, you need to understand the process which requires a logic control. Then you need to understand the various mechanical and electrical equipments which appear in that process and which need to be controlled sequentially. So you have a process, you need to understand, you need to know the logic of the control of the process, the various mechanical and electrical equipments that are used and which are need to be controlled sequentially, you need to understand. Then you need to make a list of the various digital inputs and outputs which would appear during the process of interlocking. So you need to understand the list of various digital inputs and outputs which would appear during the process of interlocking. Then the next one is implementation of implementation of logical control involves the following steps. Preparing a sequential flow control of the, after you are identifying the what is called as after you are identifying the list of inputs and outputs, you need to prepare a sequential flow chart of the complete process. Sequential flow chart of the complete process. Then which shows all the digital inputs, all the digital outputs and various interlocks. So this is termed as preparation of process logic. So you need to prepare the process logic. Then after preparing the process logic, what you need to do? You need to implement the process logic physically using any of the following methods. That's what I said earlier, the instrumentation tools, the industrial automation tools. You need to use the tools to implement the process logic. First of all, what you are doing? In the first step, you should understand the process which requires a logic control. You need to understand the process perfectly. You need to know the mechanical and electrical equipments that are being used to control that process sequentially. You need to list out all the digital inputs and outputs which would appear across during the process of interlocking. Then prepare a sequential flow chart of the complete process which shows all the digital inputs, digital outputs and various interlocks. Okay, a flow chart is to be prepared and this preparation is called process logic. Then you need to implement the process logic physically using some tools or some methods. And those methods are called relay logic. The first method is a relay logic control. A relay logic control. The second method is discrete logic module. Discrete logic module or gates. And the third one is PLC, programmable logic controllers. So for implementation of the process logic physically, you are going to use some methods. Those methods are, we have three methods: the relay logic control, discrete logic module or gates, and PLCs, programmable logic controllers. Programmable logic controllers. Then, so I am going to deal with that first topic, that is relay logic control. So a relay logic control uses a number of electrical relays. It uses a number of electrical relays. It uses a number of electrical relays connected in electrical circuits which would give results as required by the process logic. So now you have the process logic. Now you are going to use relays, which uses number of electrical relays connected in electrical circuit which would give results as required by the process logic. So this type of logic is referred to as hardwired control. What type of control it is called? Hardwired control, where you are going to physically connect the components using wires. So circuit diagrams must be designed, then electrical components must be specified and installed, and wiring lists created. Okay. So you are going to design the circuit, you are going to specify the components and install them, and wiring lists are prepared. Then electricians then wire the components necessary to perform the specific task. If an error is made in the wires, they must be reconnected correctly. So a change in the function or the system expansion requires extensive component changes and wiring. So a change in the function or system expansion requires extensive component changes and wiring. It requires extensive component changes and wiring. So this is about relay logic. So relay logic circuit control, as I told you, after the process logic is prepared, you need to implement that physically by using different tools that are available for industrial automation, and one of the tool is relay logic control. So what is a relay logic control? Relay logic control uses a number of electrical relays connected in electrical circuits which would give results as required by the process logic. So it is also called as hardwired control. So circuit diagrams must be designed, electrical components must be specified and installed, and wiring lists created. So electricians then wire the components necessary to perform a specific task. If an error is made, the wires must be reconnected correctly. So a change in the function or system expansion requires extensive component changes and wiring. It requires extensive component changes and wiring. So this relay control, logic control is used for smaller systems which consists of relay logic panels. It controls the smaller systems which consists of relay logic panels. So a relay is a simple device that uses a magnetic field to control a switch. It controls smaller systems which consists of relay logic control panel. Okay. So a relay is what is a relay? First of all, you need to know what is a relay. So a relay is a simple device that uses a magnetic field to control a switch. It uses a magnetic field to control a switch. When voltage is applied to the relay coil, the resulting current creates, when voltage is applied to a coil, what does the current do? It produces magnetic field. So this magnetic field pulls the metal switch towards it, thereby closing the switch. Okay. So it pulls the, when a relay coil, current is passed through the coil, magnetic field is generated. This magnetic field pulls the magnetic switch towards it, thereby closing the switch. So the contact that closes when the coil is energized is called normally open contact, NO. It is called normally open contact. And normally closed contact opens when the input coil is energized. Okay. So when the coil is energized, normally open when the coil is, and normally closed contact opens when the input coil is energized. So relays are used to let one power source close a switch for another power source. Okay. So relays are used to close why we are using relays? Relays are used to let one power source close a switch for another power source. So in this context, I would like to tell you about what are relays. Relays are nothing but electromechanical switches that have a coil And two type of contacts are there, that is NO. NO stands for normally open and NC stands for normally closed. When NO contact is on, so the relay will pass the current to the load, normally open. So when it is on, the relay, it will pass the current to the load. When NC contact is on, it will stop passing the current to the load. So NO keeps the circuit open and NC keeps the circuit closed. So we have two types of contacts for the relay. They are NO and NC. So when NO contact is on, it will pass current through the load. So when NC contact is on, it will stop passing the current to the load. So NO keeps the circuit open and NC keeps the circuit closed. If they are on, they do opposite job. When current passes through the coil of a relay, it makes the contacts on. Okay, when current is passing through the coil of relay, it makes the contact on. Like for example, let us consider suppose in an industry, you want to move an object from one place to another, which is generally done using a conveyor system. You know the conveyor system. So the electric motor will be coupled to the conveyor belt, so that when the motor will run, what will happen? The conveyor belt will be moving and any object that is placed on the conveyor belt will be shifted from one place to another. So to automate this task, what we are going to do? We are going to mount a sensor at the starting edge of the conveyor belt, so that when object is placed on it, it will be sensed and the conveyor will run. Now here, how this relay will perform the task? The sensor will be wired with the coil of the relay and power supply. Have you understood? So I am giving an example how the relay logic control works. Example is a conveyor system where you are placing this conveyor system is you are having a electric motor which is coupled to the conveyor belt, so that when motor will run, what is happening? The conveyor will move and the object placed on the conveyor will be shifted from one place to another. So to automate this task, what you are going to do? You are going to place a sensor on the conveyor belt at the starting edge of the conveyor belt, so that when the object is placed, the sensor will sense and the conveyor will move, will run. Now here, how the relay will be performing this task? The sensor will be wired to the coil of the relay and power supply. So NO contact of the relay will be wired to the electric motor. When the sensor senses objects, it makes the current from the power supply to pass to the coil. Okay? When the sensor senses the object, it makes the current from the power supply to pass to the coil, by which the coil gets energized and it makes NO contact on, normally open contact on. So when NO contact closes, the circuit of the power supply to the motor, by which the motor runs and conveyor moves. Okay. Normally when it is open, NO keeps the circuit open. Okay. So when the coil is energized, it makes NO contact on. NO contact closes the circuit. When it is on, what is happening? The normally open circuit will come to normally closed position. When it comes to contact, it closes the circuit of the power supply to the so what is happening? The motor is powered. The motor runs and the conveyor moves. Thus, conveyor begins to move. So this is how you are going to use the relay logic control. You are going to use the relay logic control. So the relay based control panel, it consists of mainly generally electromagnetic type of electromagnetic type of relay or thermal relays will be having electromagnetic relays or thermal type relays. The advantages of relay based control panels are, they do not need knowledge of programming concepts. You don't require knowledge of programming in relay-based control panels. Why knowledge of programming is not needed? Only thing, when the sensor is placed, the relay will, the sensor will detect what is happening. When the sensor is placed on the conveyor belt, as in the example I have told, the sensor will be wired to the coil of the relay and power supply. So, NO contact of the relay will be wired to the electrical motor. When the sensor senses an object, that is, it makes a current from the power supply to pass to the coil, by which the coil gets energized, and it makes NO contact on. NO contact closes the circuit of the power supply to the motor, and the motor begins to run. So, here no programming technique is used. Okay, so they do not need the knowledge of programming concepts. It can be applied to simple systems. The disadvantages with the relay-based control panels are, they are larger in size and they are heavier also. Components are to be connected directly, that is hardwired. Okay. They are used for simple industrial applications with simple control logic, which do not need frequent alterations and modifications. So these are they are used for simple applications, industrial applications, where simple control logics are used. They do not need frequent alterations and modifications. They are larger in size and components can be connected directly, that is hardwired. That's why they are said to be hardwired. They are said to be hardwired. So this is about relay-based control logic. Relay-based control logic. Okay. Then, what are the components of relay-based control panels? The components of the relay-based control panels are electromagnetic relays, timers, the contactors, the fuses, the MCBs, and the indicators. So these are the different components of relay-based control panel. The components of the relay-based control panel are, you have an electromagnetic relay, you have timers, you have contactors, you have fuses, you have MCBs and indicators. So the second one is your PLCs. The PLCs are nothing but programmable logic controllers. PLCs are programmable logic controllers, where when we go for the case of PLCs, they are programmable logic controller. It is nothing but a digital electronic device that use a programmable memory to store instructions and to implement specific functions such as logical sequencing, counting, and arithmetic operations to control machines and processes. So you are going to use an digital electronic device, or in other words a computer, to store to use a programmable memory, okay, to store the instructions and to implement the specific functions such as logic sequences, counting, arithmetic operations, and to control the machines and processes. So a programmable logic controller is a computerized industrial controller that performs discrete or sequential logics in a factory environment. It was originally developed to replace mechanical relays, timers, and contactors. So as I told you, in a relay-based control panel, we have electromagnetic relays, timers, and contactors. So to replace all these, you are going to use a computerized industrial controller that performs discrete or sequential logics in a factory environment. So this PLCs are programmable logic controllers. I will be dealing with the next class, next presentation. Okay. So to summarize our topic of discussion today, we have understood the concepts of automation. What is automation and its definition? Automation means to perform automatic operations by means of different kinds of machines. It is the use of control systems and information technologies to reduce the need of human work in production of goods and services. To reduce the need for human work in the production of goods and services. Coming to the definition, it is a technique that can be used to reduce the cost and improve the quality. So the most primary factor that must be kept in mind is automation is used for increasing the productivity, increasing the quality, reducing the cost, and increasing the safety in working conditions. Increasing the safety in working conditions. So automation is needed. What is the need for automation? Automation is needed to increase the productivity, to improve the product quality, to provide optimum cost of operation, to reduce the routine checks, to raise the level of safety. Okay. So these are the points that are for which we are needing automation. Then types of automation. We have building automation, scientific automation, industrial automation, office automation, light automation. Among all these, we have dealt with industrial automation. That is, what is industrial automation? Industrial automation facilitates to increase the product quality, reliability, and production rate while reducing production and design cost by adapting new, innovative, and integrated technologies and services. You are going to adopt new, innovative, and integrated technologies and services. Thus, industrial automation is needed to optimize the use of process control equipments, to decrease the response time of process and equipment contingencies, to provide information about process status, to manage process logic at floor level, and to increase overall productivity and plant efficiency. We have different tools for automation. They are programmable logic controllers, supervisory control and advisory and data acquisition system, human machine interface or touch screens, and variable frequency drives. The advantages of industrial automation are they are used for replacing human operators in tasks that involve hard physical or monotonous works. They are replacing humans in tasks done in dangerous environments, performing tasks that are beyond human capabilities of size, weight, speed, and endurance. Economy improvement, that is, automation may improve in economy of enterprises, society of humanity. Then disadvantages of automation, industrial automation. Unemployment rate increases due to machines replacing human and putting those humans out of their jobs. That is a disadvantage. Then technical limitations are there, and we have security threats and high initial costs. These are the disadvantages of automation. And coming to the last topic, that is relay-based control panel or relay based. In the relay logic control uses a number of electrical relays connected in electrical circuits which would give results as required by the process logic. It is a hardwired control where you are going to circuit diagrams must be designed, electrical components must be specified, and they must be installed and wired before performing the specific task. If there are any errors, the wires must be reconnected correctly. So a change in the function or system expansion requires extensive component changes and wiring. So the controls for small system consists of a relay logic panel. A relay is a simple device that uses a magnetic field to control a switch. Okay, so we have when voltage is applied to a relay coil, the resulting current creates a magnetic field. The magnetic field pulls the metal switch towards it, thereby closing the switch, and the contact that closes when the coil is energized is called normal open, and the normally closed contact opens when the input coil is energized. Relays are used to let one power source close a switch from another power source. So the components The advantages of relay based controls are you don't need to have the knowledge of programming concepts. They are used for simple systems. They are large in size, those are the disadvantages, and components are connected directly, that is hardwired. They are used in simple applications with simple logic, control logic, which do not require frequent alterations and modifications. The components of a relay based control panel are electromagnetic relays, timers, contactors, fuses, MCBs and indicators. So these are the topics which we have dealt today. The components about automation, about types of automation, industrial automation, need for automation, advantages and disadvantages, and the tool used for industrial automation, that is relay based control panels, we have studied and dealt today. So with this I would like to end my presentation today.